Okay, good afternoon, Matrix. I'm sorry that we have to do it this way, but at least we don't miss any school time together. So I'm quickly going to share my screen. All right, so let's get started. So the first thing I'm going to do is I'm going to go through the lesson. At the end, I'll go through the test, okay? So we're going to start with double angles, all right? So we did our compound angles. Now we're going to look at double angles. So obviously, if I've got, I'm just trying to figure this out. Oh, I draw, okay. A plus A is going to give me 2A. So that's a double angle. So if I've got 30 degrees plus 30 degrees, it's going to give me 60 degrees. So that's double of that angle, 30 degrees. So 60 is double of that angle. So when I'm looking at double angles, I'm looking for this 2A, okay? Or a double of something, a double of an angle, okay? So if we look at our cos, okay, so cos, if I've got cos of a double angle, there's three ways that I can write this. Okay, the first way is cos squared minus sine squared. So remember, your cos squared plus sine squared is your identity. It's equal to 1. But now we're looking at cos squared A minus sine squared A. Please make sure this cos comes first, okay? So it's the cos squared minus sine squared. Then there's other ways we can write this. So sometimes we have to write it in terms of cos, and sometimes we have to write it in terms of sine. So we can also write it like that, okay? If you want to find out why or how it got to that, then please come see me and I can happily show you. But we can also write it as 2 cos squared A minus 1 or 1 minus 2 sine squared A. Then sine 2A, we've got one way to write it. It's just going to be 2 sine A cos A. Okay, so those are your double angles. So if we're looking at problems involving those double angles. Right. Okay, so let's get started with some examples. So if I look at this one, okay, so I've got cos squared 75 minus sine squared 75. So immediately this needs to kind of trigger like you would with your identities. These need to trigger basically that knowledge that I've seen this before. I know that if I've got cos, let's actually do it in the block. Let's see if I can. So cos of 2A, I know it gives me cos squared A minus sine squared A. Okay, so I know that this example looks like this. So I can write that as, if I've got cos squared 75 minus sine squared 75, I know that that is my double angle of cos. So it's cos 2 times 75. So if I go cos 2 times 75, let me quickly get my calculator. Okay, so 2 times 75 is 150. Okay, so you can leave it like that if you got told to do it without a calculator. If not, if we go cos, so no, sorry, you can't leave it like that. Remember, you go cos, you've got an obtuse angle, so we need to go 180 minus something, so minus 30. Okay, so that would be a negative cos 30 degrees. We know what cos 30 is. So cos 30 is a square root 3 over 2. So this will be negative square root 3 over 2. So over here, let's quickly see what we used. So from here to here, we used that cos A or cos 2A is equal to cos squared A minus sine squared A. From here to here, we used our reduction formula. Okay. And then from here, we used our special angles. Okay, so we used a bunch of knowledge to do that one. Okay, let's quickly look at this. So remember, this is a video, so you can just pause it and copy it down. I'm going to carry on. All right, so now let's look at our formulas again quickly, just to refresh our memory. So remember, we've used this one now in that last example. We need to keep an eye out for these two and the sign, okay? All four of these. So if I look here, I've got 1 minus sine squared 30 over 2 cos squared 15 minus 1, okay? If I look at this one, I've got 1 minus sine squared, right? It does not look like this one. So remember, this one has got a 2 in front of that. But what it does look like is, remember your identities. Your cos squared theta plus sine squared theta is equal to 1, which is also 1 minus sine squared theta is equal to cos squared theta. Okay, so remember those ones. So this top one we can write as that identity. So I know that that is cos squared 30. Okay, because it follows this law, okay, or this identity. But this one, the 2 cos squared 15 minus 1 follows that double angle. Okay, it looks like that double angle. So I know this is going to be cos 2 times 15. Okay, so this makes it easier for us because we've got cos squared 30 over cos 30. Okay, so if I do cross cancelling, I'm left with a cos 30 degrees, which I know is square root 3 over 2. So from here, if you asked of how I got there, remember you've got cos 30 squared over cos 30. So if I cross cancel, I'm left with 1 at the top. Okay, so that's how I got from here to here. Okay, so just pause and take it down. Okay, and then your homework. So I'm just going to give you a few to do. Let me quickly just find it. So while I get out your homework, just quickly take out your test or pictures of your test. We're going to go through the test together. Okay. Okay, so for double angles, what I want you guys to do, let me quickly just get those. Okay, exercise 2, page 147. Okay, I want you to do A, 1 and 8, B, 6 and 13. And then C, I want you to do 1 and 3, but C is a very good question to do. So you just have to do those 4 for me. Okay, so like I said, you can pause whenever you want. I'm going to move on to the test. Okay, so let me get this test out for us. Okay, so let's have a look. So it says Chris bought a bonsai at a nursery. When he bought the tree, its starting height was 130 meters. Let me just open it up. Sorry. Okay. All right, so it started at a height of 130 millimeters. Okay, so thereafter the height of the tree increased as follows. So this was the increase in height. All right, so take note of that. First, notice the height increase was a geometric sequence, which means we've got a constant ratio, during which year will the accumulated increased height be 294,117. So it's important to use your series formula because they're looking for accumulated increased height, which means if I added all the increases together, when will it get to that height? Okay, so you used your series formula and you got that in the 6th year. Then it will accumulate to that part. So pause if you want to take down the corrections. Then if I look, okay. What height will the tree eventually reach? Okay, so we know that this is the R, okay, so the ratio is between -1 and 1. Okay, so we know that it will converge. All right, so it will get to a point where it doesn't really grow anymore. So it will stop growing. Okay, or it will grow a few millimeters or whatever. So we're going to use our sum to infinity. Okay, so our starting value is 100. Okay, because I started with that, and then 1 minus your ratio, 7/10, and you got the total growth. Okay, the growth to which it will converge to. But the question asks, what height will the tree eventually reach? So we've got the growth of 333,333, but remember it started at 130. So the total height will be our growth plus that initial height. So you got an answer of 463,3 millimeters. Then question 2, so a lot of you struggle with sigma notation. Remember, your sigma notation always refers to your series. It's the sum of, okay? So the sum of this formula will be that from T1 to whatever n is, okay? So I know that it is a geometric series, so I say Sn is equal to Arn minus 1 over R minus 1, and I work out what my n is. That would give me 381. This is saying that the sum of this is 381. So if my answer is 381, what will my n be? So it will be 7. Now remember, your A is your first term. To find your first term, you have to put in t is equal to 1, so you've got 3 times 2. T is 1, so 1 minus 1 is 0, which gives you 3. Okay, so pause if you need that. All right, that is all for this lesson. Okay, so please make sure you complete all the homework.